Lake Stevens Sewer District builds state-of-the-art wastewater treatment plant. I guess I've never really thought about where all the wastewater goes because, well, everybody poops, right? And everybody takes showers. At least, I hope everybody does that. I guess someone has to deal with everything we put down the drain. If you think about it, we create a lot of wastewater in our everyday lives. Day in, day out. I want to find out about this new treatment plant, how it all works, and what makes it so special.
According to this, it says for tours, I should see Barry Baker. Okay, here I go.
Wow, this is amazing. I can't believe it. It's like Disneyland.
Hey, Pat.
Hey.
Good to see you. Barry Baker.
I knew it was you. How are you doing?
I'm doing great. Welcome to the Sunnyside Wastewater Treatment Plant.
I cannot wait to look around.
Here it is.
Where do we start?
Well, what do you want to see?
Everything. Well, almost everything.
Well, we'll be happy to show you whatever you want to see.
Okay, I'll follow you.
All right.
Oh boy, I've been so excited to see this new plant. Balfour Beatty Construction Company broke ground here in January 2009 and had up to 70 construction workers here on site for over 3 years. This is one of the most compact sites around. Only about 12 acres can handle the wastewater of 30,000 people, and it has the ability to serve more than 100,000 people. The excavation removed over 16,000 truckloads of dirt. Most of the structures are concrete, and over 13,000 cubic yards of concrete were placed. That's enough to cover an entire football field 7 feet high. I don't know why you'd want to do that, but you could. In all that concrete are reinforcing steel and miles of electrical conduit. In fact, the main floor slab of just the equipment building has over 6 miles of electrical conduit. Wow.
Oh boy.
And now we get to tour the finished plant and see how it all works.
Starts up at the wastewater treatment plant, Headworks.
The Headworks?
The Headworks. It's where it all starts. It's where the wastewater comes into the plant. That takes all the sewage from the entire town of Lake Stevens.
Wow.
Comes into the treatment plant right here.
Right here. It happens right here, huh?
Right?
That's incredible.
What are you wearing that for?
Well, you know why I'm wearing this.
No, it doesn't smell.
Well, maybe you're just getting used to it.
No, it doesn't smell.
We're talking about raw sewage here.
I know it's raw sewage, but that's what all these covers are for. In fact, we ran this plant for 3 weeks, and the neighbors across the street didn't even know we had started it.
Really?
Really?
Oh.
You can take it off.
Okay. Hey, you're right.
Yeah, it's not
It's
bad.
fine. No, it's not bad at all.
Yeah. So this is where it all starts right here. Anything that anybody flushes down the toilet, drains through the sink, goes down the shower, from the restaurants, all these different things, it comes right in through that pipe.
Right through that
and
pipe.
drops in here.
And it goes through here?
And it goes right through here. Do you want to see what it looks like?
Ooh.
Oh, come on, let me show you.
Okay.
Just come right around over here. This is it.
Oh boy. Oh boy.
Yeah.
Okay, that's enough.
That's enough?
Okay, you can close that now.
Have you seen enough?
Yeah.
Okay, all right.
Seen
Well,
enough and it smelled enough, yeah.
even I don't like that.
I've never been so happy to see a lid closed.
That's right. But that's what makes this treatment plant different, is we've got covers on all these things. We've got vents that actually pull air in to keep all the smell away. And all the things that come in the wastewater that aren't supposed to be there is where we take and get them out of the wastewater stream. And we do that right over here at the screenings.
All right.
Pat, this is where we take out all the things that aren't ever supposed to get into wastewater.
Well, like what?
Well, there's all kinds of things that people put in there. They put in Q-tips, they put in baby wipes, personal wipes. What are those things that when you put on makeup, those?
It's a sponge. Well, I don't know.
Oh, well.
I don't use makeup.
The makeup sponges, whatever those happen to
Yeah.
be. There's all kinds of things that get put in the wastewater, flushed down the toilet, that never should be in there.
Really? Like what's the biggest thing you've ever seen?
Well, the biggest thing? Actually, the biggest thing I've ever seen was one of those big orange traffic cones.
That was me. I did it on a bet. It took me 47 flushes to do it, and I knew on the 46th that it was the wrong thing to do.
That's the kind of thing that we don't want in the treatment plant. It
I
causes
understand.
all kinds of problems, and because of that, We've got to have machines like this to screen out those big things, those things that should never be in wastewater. Now, this you can't really see what's going on in there, and if we take those covers off, it's going to smell again. But we've got some video that we shot when we were doing the clean water testing to show you how this works. Takes the big stuff out, and then it moves it over to that building right over there. Let's go on and see where these end up.
All right.
All right, Pat, here we are. This is the Headworks screenings building, where all those things that we said should never get in the wastewater get collected, washed, compacted, and put into a dumpster. The other thing we do here is we have a sampler, and that's where we pull samples for scientific testing that check the strength of the wastewater that comes in. This is the first place we do it. We check pH, we check dissolved oxygen, the strength of the waste, all kinds of components to be able to see what we need to do to treat it properly.
It's like you're maintaining a hot tub.
This is not quite what you would want to get into.
No.
Probably not.
Want to move on?
I think so.
All right.
So Pat, as you can tell, this plant's a lot different than the old treatment plant.
Yeah. This is not your father's waste treatment plant.
No, it's not. It's very different.
This is the old Lake Stevens plant, first built in the 60s and upgraded several times in the next few decades. This was originally built to serve 1,500 residents, and the population has grown to 20 times that many people. It did its job, and it did it well, but growth and higher water quality standards made it necessary to expand or build a new plant. One of the challenges of the old plant is that it's located in a floodplain with very soft soils. Any expansion there would be really expensive. The aeration basins with these giant mixers that add air to the process weren't big enough or deep enough to handle so much volume, and it could never meet the new treatment standards. The old plant is not nearly as efficient as the new plant, and it certainly isn't as pretty. If you were standing at the headworks of the old plant, you could really smell it. Whew! Boy, could you smell it. But many of the processes you see here, the basic biological and physical treatment, are much the same at the new plant. But the big difference is the biofiltration at the new site. These bad boys, these membranes, they're the stars. We're going to learn more about them later. The other difference is how tech the new plant is. From what Barry tells me, everything is computerized. This is a glimpse at mission control. Wow. These operators can monitor how much flow is coming in, how much is going out, and keep everything flowing just so. They can see which pieces of equipment are operating and if they're using too much power or not. There's more technology here at this plant than on the space shuttle. Cool, huh? Let's get back to the tour.
So Pat, we've already seen what happens at the Headworks. We take the big stuff out, we clean it up, the water comes over here, and now we're at the primary clarifiers. And you can see the water that comes over here, it still has stuff in it.
Yeah, it sure does. I wish I hadn't thrown that mask away.
Well, it does still smell here. That's why we've still got the covers over this whole system. But there's stuff floating in the water, there's stuff moving around, and that's the purpose of these primary clarifiers, to get rid of all that stuff. And this is where we have what's called physical treatment. We just allow the particles to settle to the bottom or to float to the top. We rake it off or skim it off the top. We can see that right over here.
Okay.
So Pat, here you really can't see what's going on. First of all, we've got the covers on it, and second of all, it's pretty dirty water. But we did shoot video once again during that clean water test, so you can see what's going on there. We can see a little bit of it at the other end. Let's go take a look at that.
All right.
Once the water's gone all the way through the primary treatment, it gets here, and all the stuff that floats to the top, you'll notice it collects right here against that pipe that's got the hole cut in it.
Yeah.
That's a scum collector, because this is scum. Scum.
Scum.
Scum.
Scum.
Okay, let's talk about scum for a minute. Who can resist that? Barry says that scum is one part of the solids that need to get out of the wastewater stream. The scum is something that can be seen and has to be dealt with, but it's only a small percentage of the solids removed by the primary clarifier. Most settle to the bottom and are collected below. See, the liquids flow through the plant in sort of a big U. At the primary clarifier, we take out the solids that have settled to the bottom or floated to the top. These solids are sent to digesters. Yum. The digesters are kind of like huge crock pots that are heating up and cooking the solid waste. They heat up to human body temperature, interestingly enough, and they produce methane gas. Interestingly enough, like humans do when they... you know what? Let's not talk about that. The methane that's produced by these digesters, the smelly gas, isn't just let out into the atmosphere. It is burned and used to heat the digesters as well as heat the rest of the plant. Even the smelly gas from the waste is not wasted. Now that the solids have been baked, big machines squeeze most of the water out of what is left. And the final product is called cake. Yeah, cake. It's not the kind that you'd want to eat, even if you were really hungry. But it is great for loading into trucks to feed wheat fields and forest land and to help plants grow. So let's get back to the wastewater flow.
Wow. Hey, that sounds pretty cool. This must be the plant's echo chamber, huh?
Yeah, lots of reverberation in here.
Sure is. Very cool. Very cool.
Actually, this is the primary effluent screenings building.
Yeah, you know what? That was actually going to be my second guess.
These screens are much like the screens that we saw in the Headworks, except that the holes are so much smaller that we're trying here to capture even things as small as human hair.
Really?
Because hair causes a lot of problems in the treatment plant, as well as those in your plumbing, like your sinks or your drains. But anytime you got a shower, you're going to have hair getting into the system.
Yeah. Well, where does the hair go after you recover?
We take it out of the screens just like we did before. It goes down those chutes and to another compactor.
And off to the hair factory.
And off to the hair factory. But the other thing that was interesting about this room is right over here we have another big pipe. So this is the OCD, or odor control duct. And this is a big fiberglass pipe that goes throughout the entire plant. And as you can see, it grabs air from all these inlets and it goes into here, into a big fan, and to a filter where it cleans up the air. And we'll go take a look at that next.
Great.
Right out this way, right out the door there. So that odor control duct from all over the plant, it sucks air, and inside this room are great big huge fans. There's 2 of them. And they pull all that air, but they go over here and it goes into these filters. And these filters are really big piles of wood chips. So these are the biofilters, and all the air that we've pulled out of the entire plant, pulled through those 2 great big huge fans, gets pumped up through these. And in the bottom layer, there's limestone, and in the top layer, there's basically, well, it's wood chips. What this does is this filters the air. So all that wretched smelling air that we had at the Headworks, the primary, you remember all those?
Oh boy, yeah.
This is where it all comes out. But it's kind of like a carbon filter, except, well, wood is carbon. It's just not as processed. And so it's inexpensive and is able to do the same job, and it cleans up the air. Let's go look at the aeration basins next. So Pat, here we are now at the aeration basins.
Yeah, you no offense, but I think you got to get some chlorine in this pool.
Well, that's the difference. In the primary system, we were doing the physical settling to where it was just gravity taking it out. Now, we've actually got biological treatment going on here. That's where you've got all kinds of microorganisms, algae, different things eating up all those nutrients, eating up all the biological material that's in there. And so this is a much different process. Different bugs like different environments. There are some bugs called anaerobic that don't like any air at all, and they don't want any additional nutrients. And they are in what's called the anaerobic zone. Then there's some bugs that like lots of air, and those are called the ones that like the aerobic zone. And they're all taking out different things. Some of them target the phosphorus, which is a nutrient that we get into the system. Some of them target the ammonia that's created, and it becomes nitrogen gas and just bubbles off, which is harmless to the environment. But it's a problem when it's in the water. And then some of them are actually eating that organic matter that's there and breaking that down into its constituents that will get passed out through the sludge in the rest of the process.
You know, it finally occurs to me there's a lot of science involved with all of this.
There's a lot of science that goes with all this.
Yeah.
Barry tells me these bugs are really bacteria, microscopic bacteria. Operators who work at the plant take samples and they do testing every day at several stages of the treatment process. They're making sure everything is in balance to keep the physical, chemical, and biological processes functioning. They deal with surprises that come down the pipeline, chemical surprises, Like if, someone uses too much Drano, for instance, that can kill the bugs they count on to keep this plant working correctly. First, these operators have to investigate what might have caused the problem, and then they do what it takes to get things back in balance. Now remember how we said this is like your hot tub? Well, in your hot tub, you want to kill everything. Well, except the people in it. But here, they're actually trying to keep the good bugs, the workhorses, alive and well fed with sewage, while neutralizing the toxins that come in that could kill them. It can be a tricky process. Good thing we have these scientists and these engineers and operators to keep it all straight.
Pat, now let's go on to the next section. What we've done so far is we've done primary treatment, which is settling by gravity, and now we've done biological treatment, which is here. The next step is we're going to actually take this mixed liquor, that they call it, and we're going to pump it into some membranes, which is actually going to filter out all that stuff that you see there. So what looks like really scummy brown stuff is going to become crystal clear water. And we do it through these right here, these membranes.
Barry, I must say this is a lovely set of curtains you have here.
Well, they might look like curtains, but these are the membranes. This is the heart of the system that this treatment plant is built on. Each one of these is actually hollow inside. It's like a straw. And so as that wastewater, that mixed liquor that you see over there, comes in contact with these, it gets sucked through and all the solids stay on the outside, and clear, clean water comes out and piped through the inside.
Wow.
But the problem is, of course, is just like a straw, like if you've got a strawberry lemonade or a milkshake.
Something gets stuck in there?
And it gets stuck in there. The same thing can happen to these membranes. And so what we do is we have a lot of air bubbles that come up and they actually shake these back and forth so that it breaks that stuff off. Then, even if that gets plugged at that point, we can actually pump clean water back through the membranes and blow that straw and that strawberry right off. And so it keeps these clean so that we can pull clean water out. When it comes out of this, it's essentially clear water.
Cool.
These are the actual membrane basins here. And if we take these covers off, you can see that same brown liquid just bubbling all over the place.
Yeah, I'm going to see it in my sleep tonight, I think.
You probably will. There is enough energy in that to shake all those membranes that we saw before. And if you look at that, you can see why I showed it to you over there. When this goes through, some of the water gets pulled out. But some of it is going to cycle all the way through and go back through the aeration basins. And in fact, the average is 4 times around before it goes out. So this is constantly mixing, constantly keeping it clean. And this is one of the reasons why we're so worried about the human hairs, is because they can get wrapped around those, plug those straws, and create some real problems. Once it leaves here, once again, it's clean water. So Pat, you asked me about all these pipes. Some of these pipes are taking air and blowing in. Some of the pipes are taking the water out and sucking it into the system. And some of them allow us to backflow or to clean the pipes. Now we're ready to go see the very last step of the treatment process, where we take all that clean water and do the final disinfection. So Pat, here we are, and all the water that was coming through those pipes come in here. This is the UV disinfection room.
UV meaning ultraviolet.
That's right, ultraviolet disinfection. So what this does is anything that might have got through those membranes comes in here, and we have ultraviolet light. What that means is that it messes with the DNA of whatever might get through here. And they can't reproduce. And if they can't reproduce, they're not going to hurt you. The types of things that could get in here are, well, we talked about some of those viruses, but they're pretty small. But if one of those membrane filters were to break, it's possible that some of that mixed liquor could get in here and not have everything removed. In this treatment system, this will kill everything that's there so they can't reproduce.
That's good.
And it's clean water. It's so clean that we could actually reuse this water. You can use it for watering golf courses. You can use it for commercial uses. It's actually got commercial value. And so the water here, in fact, is probably clean enough to drink.
Sure, why not?
Pretty clean water here, Pat.
Here it comes.
And there's what leaves the plant.
That looks sparkling clear.
Pretty clean, don't you think?
Yeah. Good to the last drop.
Absolutely. In fact, this water, probably clean enough to drink. Bottoms up.
Yeah, I agree with you. Bottoms up.
Yeah, I think so.
I'm trying to cut back on the water anyway.
All right, let's go see where it really goes.
All right.
So there you are, Pat. That's how it works. All that dirty wastewater that came in at the Headworks has now been cycled through the whole plant, and it ends up right out there. That's EB Slough.
Oh, yes. I just saw a guy go by on a boat there.
Yep, that's right.
That water's clean.
That water is very clean. You know, the water that comes in here, it takes about 2 days to get all the way through the system because it has to cycle through all the different areas. And of course, as more comes in, the old stuff goes out. But it takes quite a while for it to get all the way through. And there's been a lot of treatment that's gone on to make the water what it is.
So if you think of the water that went through here as a visitor and now it's in the EB Slough, it'll probably come back again someday.
It'll probably come back again someday.
That'll be a grand day, won't it?
It will.
That kind of a reunion.
Yep.
Well, this has been great, Barry, but I gotta go.
No.
I mean, I really gotta go.
But
no,
what
I
happened
mean,
here? No,
I gotta go. I gotta go.
Pat.
Man, I'm not gonna make it.